Today, we'll be talking about MongoDB. So I'm pretty excited about this. Quick introductions. Um, this is Praveen, joining in from Virginia today, East Coast, USA. I work as a staff developer advocate at Hasura, but which means I get to talk to users, developer community at large, and architects who are using or trying to use GraphQL and or setting up an API platform in the organization. So I help set up modern data access practices. And I've been working in this space for over like 10 years now, with a little bit of GraphQL experience, a lot of front end and a little bit of back end as well. So that's broadly me. You might have seen me in other webinars if you've joined in any of the Hasura ones before, but there you go. Quick agenda for today. We'll look at the architecture of the whole setup. What does Hasura do, and where does it fit in the architecture, and how do you like efficiently access data, right? We look at the larger subgraph and supergraph story, where we'll add MongoDB as a subgraph, and we'll get into the details of how. We'll also look at the automation, API automation capabilities, what kinds of things that you can do with the API for MongoDB on the GraphQL side. And we'll delve into performance with a focus on that, especially because with GraphQL, it's a pretty interesting topic. And we'll look at how Hasura is able to do high performance here, and we'll touch upon security as well. And how all of this like leads into the larger supergraph story in an organization where you have like multiple sources, and that could be like one or more MongoDB instances, but then you could also have other data sources. So we look at how all of this ties into a supergraph, and then we'll also like go over a live demo that I'll showcase today for the GraphQL API. Awesome. This is the architecture, and for those of you who are new to Hasura or just getting started with Hasura, basically data API platform, which sits in front of your data sources, and there's lots of consumers there which can access those data sources through this API platform, right? So you have let's say that you have data sources that you have as input. And it could be like MongoDB, your REST APIs, your relational data stores. What Hasura can do is it can connect to all of those sources and give it some metadata, give Hasura some metadata about what those sources mean, which could be like what tables exist, what collections exist, what are the relationships and dependencies between them. So just give a bunch of configuration, which is technically metadata. And once Hasura has that, it will be able to like introspect the databases, get this API generated for all of your data sources. And with the metadata, what is also possible is you'll be able to establish relationships across multiple sources. So let's say, for example, you have MongoDB, and let's say you have Postgres, and you have some data that you want to join. You just declare them in just YAML config to say that, hey, the column coming in from Postgres and the field coming in from MongoDB, they have the same constraint, and you want to like merge that data for the end consumer to be able to access it in one place, right? So all of this is annotated with metadata. So it's like a metadata-driven workflow, this entire API platform. And of course, once you have like a single GraphQL API or potentially like multiple REST endpoints, you can consume it through whatever clients. It could be like your web apps, your mobile apps, or your internal apps as well, with this API, right? Which also means you need authentication and authorization. And authentication, you can bring in your own provider, and authorization rules are part of your metadata. So we look at that example as well. But this is the broader architecture where you connect your data source, customize how the API should look like, add in some business logic as well, and then consume it on the end consumer side. And we'll go over domain modeling first, and why that is important to get started, right? In MongoDB, you have collections, and what Hasura needs to understand is what collections are you trying to like access in MongoDB. So you will basically tag them as models here. You also need to tell Hasura who's authorized to access these collections. So that would be like permissions, and there could be relationships between different collections, or there could be relationships between one data source or one collection in Mongo and an external API that you already written or probably might be writing. So that will be relationships, right? So you have annotations for all of these three, and then you create like a metadata configuration, which lets Hasura do all of the magic that's able to do, right? So that's a lot of abstractions here of these collections, permissions, and relationships data. These abstractions are like converted into Hasura metadata, and you'll get like a semantic graph API eventually, right? And the interesting bit is the relationships work not only between the collections in Mongo, could be between different instances of Mongo or different data sources altogether, right? And this kind of metadata-driven style where you're able to annotate these relationships and permissions makes it a lot more flexible, and probably we'll understand the benefits a lot more better once we start doing those two sources demo. And coming back to the API as metadata concept, metadata is fundamental to how Hasura DDN is able to operate, and you can look at like an example over here on the right, where there's an example of metadata which is introspecting like a MongoDB and like has derived these information about a model called users, and it has like a bunch of fields over here. So you have like a collection users, and you have like ID field, there's an email field, then the name and password and whatnot, right? It has type information as well. But this is sort of an example of what one part of a metadata will look like. And you will have like metadata for all of your collections, your permissions and whatnot. So combined together is your API, right? This gives a lot of flexibility and benefits here, and the first important thing is like you're able to now track changes over time. You'll technically understand who has made this particular change. Let's say if somebody wants to change his collection users to something else, this metadata will be version controlled in your Git system or any other version control system. And you will be able to track who's committing these changes and who's looking at all of this, right? So changes could be tracked, audited over time. So your API is always monitored, right? Both from internal changes and updates to the external consumption side. And you're able to create like abstractions with metadata. The fact that this is coming in from like MongoDB, but technically this could be swapped out with another database as well, or another instance of MongoDB with different fields. This is all abstractions at a metadata level, right? Eventually leading to like a semantic graph. The next benefit of having metadata-driven workflow is, obviously like a CI/CD pipeline, where you're automating all of the workflows with this configuration, right? You're able to now test every change to subgraphs and the supergraph. So by subgraph, you mean what I mean is a MongoDB or one data source connected to Hasura, or multiple data sources that are connected to Hasura, which a team manages. So there could be like multiple teams in the organization, and each team could be managing a subgraph of their own. Now, testing these changes and where different teams and different team members collaborate, a metadata based workflow would let you make these changes. This is a bunch of configuration. and like do a deployment and just trigger these test cases, right? So you'll be able to like move fast without any dependencies between other teams, as you're able to now have this metadata in multiple places. Cool. The core demo of this webinar, which is to showcase the API automation capabilities of Hasura. So we look at how there will be like a standardized API, and what Hasura lets you do is standardize the API not just across one source. You'll be able to now get a standardized API across multiple sources. And the good thing is that you can swap out data sources, you can swap out your models and whatnot with these, because the API structure predominantly stays the same because it's standardized. And I'll show you what that means. Technically, if you're building like a REST API, and if you want to do like filtering logic, your sorting logic, your pagination, or just the ability to do relationships, you would have some sort of a syntax, which is like an internal knowledge as well. You do have Swagger spec with the REST APIs, which that tells you what this API does. With GraphQL and with the metadata structure, with the standard syntax, this all becomes pretty easy and pretty intuitive to understand. And all of these becomes like capabilities which go through multiple sources as well. So you will have like a standard experience across different sources of data. Let's say you have started with MongoDB, one instance, and you're able to like filter, sort on your collections. And then now you want to like add the same capabilities to another data source, like your custom business logic that you had written for your Mongo instance. You would also want to do some of these capabilities there. And Hasura's API layer would let you do that much more easier than trying to think through it from scratch. And the good thing about metadata as well is that you can keep adding new domain models pretty easily. Like you just modify a bunch of config and then you either add models or update models in pretty quick time, right? And you can also like join, as I mentioned before, across collections and databases and APIs, and which is another capability that we look at in the demo. I wanted to also like stress on performance here. And this becomes an interesting topic with GraphQL in picture, because you have like broader concerns like the N+1 query problem with GraphQL, which is sort of addressed with a data loader pattern. But when it comes to like a database request, database query, you would typically want a fewer number of hits to the database, keep the database load lower, and get efficient data as much as possible. So do not overfetch from the database, make lesser number of queries to the database. Those two are probably like primary constraints when it comes to getting like high performance. And with MongoDB, especially with the document store, you're bound to like fetch more data than necessary, especially if documents differ in the kinds of fields that you have. So it's important to actually fetch exactly what the query asked for, which is also the GraphQL benefit, right? And Hasura is able to do query push down, and the query to the database and get it back in one shot. And it's able to do it with aggregation pipeline in MongoDB, which we look at in detail with a demo to see what that query will look like. But here's just like a sneak peek into what a GraphQL query will look like as an equivalent MongoDB query if you had to write your own optimized version of a query, right? And in this example, I've just taken the sample database from Mongo, which is the movies database. I'm trying to fetch one record ordered by the release date. So I'm trying to basically fetch the latest movie that's there in the database. with a bunch of fields here, right? And if you look at the aggregate pipeline that's over here, which is like stages of a database query, you have these parameters pretty much configured. So you have the sort parameter, you have a limit one, and you'll also like fetch the right columns, and if not, return null. So this is an aggregation pipeline that gets sent to MongoDB for execution, and that'd be like one database query as opposed to like making multiple round trips to the database, and also like not trying to fetch every single field in the collection in the document, and then trying to optimize on client, which is not a particularly an efficient way to do it, right? And especially when the data size becomes large, you would want to like focus on efficiency and server-side filtering before sending it to the client. Cool. Which also then now brings us to the bigger picture, which is the Hasura Supergraph. And if you look at here, we've just touched upon the subgraph of MongoDB here, which again, that could be like multiple teams collaborating. And you could have another relational store, let's say in this case, Oracle, that could be other custom APIs, another team could be working, and there could be shared resources between them, right? Hasura Supergraph basically sits in this layer, abstracting away all of this data sources to give like a unified semantic graph connecting to all of this, and gives you like a one composable API, which is standard, self-service, access to data, irrespective of wherever they are, right? And what kind of APIs they are. And to do that, you need like a good distributed execution engine because technically consumers could ask for data from any source here, including Mongo, but then the distributed engine should work well for this performance to kick in. And also federated ownership, where different teams are working on it. Now, who gets to decide to change metadata about relationships between them? That's an interesting topic as well. But the fact that the metadata workflow enables teams to like collaborate on this unified API without conflicts is pretty interesting. Clients could also like connect to services directly if required. So for example, there's like an internal use case where you don't need to go through that super graph of an API for unified semantic graph. You just need access to this one particular source, which is this subgraph built on top of Mongo, where teams are collaborating. You could do that as well. So you should be able to now access your subgraphs independently, but then also access Supergraph, the unified graph, also seamlessly. Now this also like assumes that there is like authentication and authorization taken care of, and all of the other peripheral benefits for like a production level API, which is how do teams iterate, how do they proceed faster with changes, CI/CD deployments, and collaborate across different teams without any dependencies. So that's all part of the characteristics of Supergraph, and the bigger idea is that you reduce all of this complexity with an abstraction with metadata, which gives you like a composable GraphQL endpoint. And by composability, what I mean here is the ability to like merge and compose and like have a standardized API experience across different sources. Cool. There's probably enough talking done. I'm going to look at a demo. Cool. I am on my VS Code instance, and I have an empty directory from MongoDB. And what I'm going to do is I'm going to initialize a supergraph for Hasura. I already have the DDN CLI plugin. So the prerequisites are you need to have the Hasura CLI installed on your machine, and that's it, which means you should have an account on Hasura DDN. and just authenticate that with the CLI, and you should be able to quickly start running here. So I have the latest version of the CLI, so I'm going to do this demo with this one. And the first step here is to initialize a supergraph. So I'll do supergraph init on the current directory. Okay, this seems to be not empty. Let me remove all the files. Yeah. Give me 1 second. Let me do supergraph init. Not empty. All right, let me create another directory, which is webinar inside this one. And let me initialize this. Yeah. Cool. So there's like a bunch of files being created as I initialize as this supergraph. You can see there is like a bunch of configs here. There's like a supergraph.yaml. Let me close this terminal now. There's a supergraph config, which points to like a couple of subgraphs here. There is a Hasura.yaml, which tells you the Hasura version here. There's a compose file, which builds a few Docker containers for you to run it locally. And we'll look at that as well. There's an env to start the configuration credentials for all of your subgraphs. There's a global subgraph with some configuration for auth, which we'll come back to later. And then there is like an app subgraph by default, which is currently empty since there's no data here, right? So let me bring back my terminal. The next step would be to initialize our MongoDB connector. So I'm going to do alien connector init -i, and this is like a CLI quick start wizard that we've created, which lets you go through these steps pretty quickly. So here, this connector initialization has a few default connectors that you can choose from. Let me zoom out a little bit. And we have Postgres, Node.js, and MongoDB, among other connectors. I'm going to look at MongoDB in this case. I'm going to give it the default name, default port for the connector to run, and it requires the MongoDB database URL. I'm back here. I'm pasting the connection string URL over here. I need to replace the DB password, which I will do in a bit now. And I have put in the password here. And I'm also going to use the database, the sample database that comes in with MongoDB, which is like a movies database. It has some data about movies, IMDb collections, ratings and reviews, I suppose. So this is the connection string for your Atlas. I've also ensured that the Atlas database on cloud is open for network access to both my IP and also probably like generally open to public for now for this demo. But you should be able to like restrict access to the right IP for Hasura as well, or for your own IP for local development. But broadly, this is the first step here. You put in your MongoDB connection string, and that should be it. Now we've added it, right? So it has created a bunch of files. If you look at the connector, there's a mongodb.html, which has this standard config. And currently, again, this is empty because we've just initialized a MongoDB connector. Now, the next step is we need to introspect the database to understand what the collections are. And to probably show you what those look like on the MongoDB side, I'm going to quickly share my Chrome to tell you what the database looks like. Cool. This is the connection string, connect data. What I'm going to do is going to show you the collections here. So browse collections. Yeah, so this is the sample database that I mentioned. This would have comments, movies, data, and users, a standard schema for your movies collections. So we have all of this, with a little bit of sample data as well over here. And in fact, movies has a lot of documents which could go in with nesting as well. So we look at relationships over here. Cool. Now the next step is I will introspect the database. Give me one sec. Gonna share my VS Code here. Sorry about the back and forth. But now the next step is I'm going to do Debian connect introspect MongoDB. And let me also verify if my Docker is running. I'm going to quit this one. Recheck if my Docker is up and running. Live demos are always tricky. I've restarted Docker. I'm going to rerun the command to introspect. And there you go. So what this command technically did, I think it created a container to introspect the DB, loaded the metadata, but after the introspection is done. And again, it destroyed the container after the initial task of introspection is done, right? Cool. So let's look at configuration.json inside the metadata. So there's MongoDB, HTML. And now you look at this particular document, you can see that it has introspected the database to generate these types and these operators after looking at all of the collections over here. And you can start seeing that it has introspected these collections with these fields, which is just email, movie ID, name, text. So you start seeing all of these fields appear here. Cool. So now that the introspection is done, the next step is that we need to tell Hasura what collections are required for the API. Right? Right now the API is still empty. We've just done the introspection. We have the metadata ready, but now we need to tell Hasura, hey, I need these collections as APIs. So the next step would be I'll basically track all the collections here as models, just for this particular demo, but you can pick and choose which collection you want and what those names are as well. So in this case, I'm just going to do a MongoDB star. So the command is basically DDN model and MongoDB followed by the star, which just adds all collections. And you can look at the logs over here, which just says it has added model for collection, comments, there's embedded movies, there's movies, sessions, data, users. Pretty much what we saw on the Atlas screen as well. So it has already done the introspection, and now it's able to also like add the API bit as well. The next step is I'm going to also add relationships that exist for this graph. And you can also see that there's no foreign keys because there's no concept of foreign keys here. So nothing to add here at this point. Now I'm going to do a DDN Supergraph build local. This will build the current metadata for a local build. And to start the local setup, I'm going to run this command, which just opens up a bunch of Docker containers. And I can show you what is running as well. Over here, so we can see there's like 3 containers. There's a MongoDB connector, there's a Hasura engine that's running, and there's like a telemetry setup which is running. So they're like very simple 3 connector setup that you can see. Now, me reshare my whole screen so that it's easier for Chrome setup. Cool. So now I'm going to go to localhost 3000 to see all the APIs that have been generated. You can see that on the left, there is like comments, movies, users, and everything. Right? So let me start doing a simple query to do movies. Let's fetch the ID. Let's fetch the title. Let's also limit the number of requests. Let's say I want the 5 movies. And I want to order it by the release date in a descending order. And we've gotten the response. And to quickly maybe confirm, we'll also like browse the collection to see if they should technically exist. But we could also, there is a quick way to search here. Okay, never mind. This probably has too many data, but you get the point. This is data coming in from MongoDB, but it's still on our local machine. This localhost 3000/GraphQL. This is still running on our local setup with Docker. Although this URL is console.hasura, basically pointing to localhost 3000. Now the next step is to deploy this to like a cloud project so that people can also like start consuming it outside, and also other team members can start collaborating on this project. Now, as a next step, I'm going to do a Debian project in it, which is the cloud project being initialized. And I'll also do a Supergraph will create. And this will do the build on cloud. And this might take a few seconds as we speak, which means I can look at Q&A to give you some answers. And there's a question right now, which is about, can the metadata be consolidated together when there are multiple different data sources? So the way the metadata works, at least from a file structure, is each subgraph will have their own directory with their own types and like the tables or models that you're defining that are being tracked. So each subgraph will have its own setup. This means that each team working on that would contribute to that directory. And if there are like newer subgraphs that other teams are contributing to this whole supergraph, that could be a separate directory, not part of the original subgraph directory. And that's how I think you should be able to collaborate as well, even though there are multiple data sources. Is the metadata the equivalent of subgraph schema? So the metadata is your entire Hasura project, is your entire API, right? It tells Hasura what are your data sources, what is the auth rules, authentication configuration and authorization rules, what collections in Mongo are you tracking, what tables in, let's say, Postgres are you trying to add, what are your REST APIs. So you define all of those in metadata. So it is equivalent to your entire API project with custom logic code that you would write that you'll also bring into this project. So it's essentially think of it as like your API blueprint. And this could definitely have more than one subgraph, right? So it's not just an equivalent of one subgraph. I hope that answered that. There's another question on chat, which is, can you work on Hasura Workspace for free? Yes, Debian Basic is free. In fact, whatever I'm showing you right now is on the free tier. Yeah, that should totally work for you. Meanwhile, let me look at the build that's happening on cloud. seems to take a little bit of a time. Could also be like network. Maybe I'll share my screen to show you the metadata differences here. And the build is happening as we speak. But Sai, to your question about each subgraph having their own metadata. So right now you look at this directory structure, this app is a subgraph, which has just right now MongoDB, but technically you can add more subgraphs to this, more data sources to this. So you could have, and we could also do that in the example where we can add Postgres to the same subgraph, and could be like the same team working on that as well. Or you could create another subgraph, which is a different directory, let's say like a Mongo subgraph from scratch, which is a different Mongo instance, or could be like a Postgres subgraph, or an Oracle or a MySQL subgraph, which is a different team working on it. They can create their own subgraph and then push it, and it'll appear as a different directory over here. And broadly, you can look at the fields over there. And I can also show you the Supergraph visualization as we speak. So look at the Explorer over here. This will give you like a good overview of what the subgraphs are. Right now we have the Supergraph over here, which is connected to like global subgraph, which is just a bunch of configuration for your authentication and a bunch of other stuff. And this is your app subgraph, right? Which highlights that it currently has like a MongoDB source pointing to like a few collections that it has, right? And I could go into a particular collection, like this is the users collection. This could be like the movies one. You could also like look at what the permissions here are, right? And this is all like information that is read from the metadata. The metadata is being fed into the console to be able to do this. You should also be able to visualize this relationship as you keep adding more sources that you see here, right? The build seems to be taking a little bit more time. So what I can probably do is show you an existing project which has the same schema, deploy to cloud, so that I can show you the performance differences. ID, titles, released, and just probably like 3 fields to get started. And again, the MongoDB one is running on free tier, so it could be also on a cold start as we speak. Yeah, let the server get started. See that involve a request going on. And I will look at chat as well. Yeah, I will change the Zoom header, which is blocking the view. Sorry about that. There's another question about defining relationships, and I will show you that in the metadata. It looks like Mongo cluster is taking time. So I'm not able to deploy this or show you the cloud version of this. I wanted to basically show you the performance before we head out for the relationship example. But I can show you an example from this query that I tried making. And this was the movie's ID, title, released, and then whatnot, right? Looks like the query execution plan is still loading. So let me show you a previous example, which is for a slightly different query, which is movies ordered by ID, cast. So like basically like 5 fields being fetched here. Let's wait for the query execution plan to load. Meanwhile, I think I've gotten my console build. And this is from the project that we just tried out. So let me make another query, ID title for now. There's probably something to do with the Mongo cluster. Now we've gotten the response. Slow, but I think it was due to the full start time. But the point that I wanted to show was this tracing, which tells you what the exact query to the database looks like. And you can see that that will be like an aggregation pipeline and how much time each part of the query took. And this is the database query plan, which is for this particular GraphQL query, which is just movies limit one ID title. This is the equivalent database query plan that would get executed. And this is like an aggregate pipeline. This is for movies with the limit one, and there's like parameters for ID and title, and the conditional check to see if they exist, send the data, or if not, send it null, right? And cursor to point the pagination logic as well. But this is what exactly that gets sent to the database, and this is why the performance will be high if you're like fetching lots of data, where you will exactly fetch the right columns, and you'll also like fetch the right number of rows from the DB instead of making n+1 queries or instead of overfetching large amounts of data. And again, this is like the observability dashboard where you'll be able to like introspect queries that are happening, introspect performance issues, debug them and whatnot, and look at error rates and whatnot. On the free tier, you obviously have like a 15-minute data, but you can upgrade that for like larger data set. Cool. There's probably a couple more questions on chat. Let me look at it. I think Annie had asked defining relationships, right? So yeah, I will share that example. I will go into VS Code. Give me one sec. Yeah, let me hide this one. Cool. I wanted to show how to add a relationship, right? So if you go into metadata over here, and you can see that there are like these collections that we just tracked in from MongoDB, which is movies, sessions, users, and whatnot. And you can see that there's this is types permissions, and just so that we are here, you would create more permission rules by just adding more roles, which is could be like, hey, you could call this as a user role, and you can tell Hasura what fields are allowed. And in fact, if you look at our current query, if you don't give the token or use the admin role, you'll not be able to fetch all of those, right? So you can keep adding permission rules here in metadata, and then tell Hasura what fields this particular role is supposed to access. That's part of the permission rules. And similarly, you should be able to set up a relationship, right? So I'm going to like collapse in all of this details. There's like a bunch more. Let me go to the bottom, and I would do kind relationship to model. And you can see that I'm using the Hasura VS Code extension, which helps me autocomplete some of this, right? But you could you should be able to like replicate this on your side. And when you're trying to define relationships, you could give this metadata the relationship name, which in, let's say, from movies to users, let's say movie underscore user or some other casing, let's say camel casing. Could you have to tell the source type, which let's say MongoDB in this case, the target model, which is the name of the target model, let's say user, the relationship type, which is either an object relationship or an array relationship. Is it like a one-to-one or one-to-many? And you would define that relationship. And the mapping would be from which field in, let's say, the user column and which field from the movie column, right? And I would just, let's say, the user ID. So you would define the relationship in this kind of a metadata-driven workflow. I've probably made up these fields here, but so this may or may not build, but this is how you define a relationship for MongoDB or for like any data source. The good thing is that here I say the source type is Mongo. This could be from any source. And the target field could also come in from any other subgraph, any other models, not necessarily restricted to just MongoDB in this case, right? So that's how you will go about defining relationships. And this is for movies. You could go into any collection that you are looking to add this relationship for. And as soon as you do that, you would typically open up your CLI and then do a Supergraph build local and build create to start deploying and testing that locally. And that's how you iterate on these models. So adding a new domain model would also be as simple as saying DDN model add MongoDB. Let's say you added a new collection, which is, let's say, products. You should be able to do this pretty much similar to how you just add collections to your database. So as soon as you make a change in database, you should be able to do that. You should be able to sync those changes back into your metadata and build the metadata and then give Hasura this build, and you should be able to apply that as well in your final build. So I'll show you what that will look like. So currently you're on the latest build. As you keep building, as you keep changing, iterating on the API, you should be able to start looking at more builds over here. We have probably 4 more minutes. If there are any more questions, I'm happy to quickly take them. And meanwhile, I will see if I'm able to like quickly add another data source to show you the power of Supergraph. So here, what I'm going to do is Supergraph. I'll do a connector in it. And I'll try to add a Postgres subgraph very quickly here. I'm using the default sample app connection string that is there in Postgres. And I'll do introspect Postgres, and I'll also add all resources here. Again, let me quickly look at Docker setup. Give me one sec. It will run this now. Yeah, and let me do a build local. So I'll just do this local setup first. My Chrome. Now I'm going to refresh this. This is not the local one. Yeah. So now I can see that in my Explorer, I can see there's an app subgraph with Postgres connected and like a MongoDB connected. And to quickly show you a query executing from MongoDB, let's fetch products, field limit 1, ID name, and you get this product, right? So, and again, you should be able to introspect and see what the queries are from this. That's pretty much what I wanted to cover. So in a summary, we've basically done like a metadata driven API with high performance because it's able to do query push down and security rules as part of your metadata. And you should be able to get started with this, right? So I'll drop this link on chat. There's probably multiple links that I will send everybody. This is the getting started link for Hasura Docs. This is our connector, which is open source. So I'll drop the link for our connector as well. And I'll also drop the link for the product page from MongoDB. Which will give you like what features exist today in MongoDB, which should work for your use case. Yeah, that's pretty much what I wanted to share. Let me do MongoDB, and you'll be able to see what the features of this API looks like. This filtering, sorting, aggregation, and probably vector search as well, which I wanted to cover, but in the interest of time, I've kept it simpler. But yeah, feel free to ask in more questions on Discord as well. Post this call, and I'm happy to help as well. Yeah, that's pretty much this webinar. Thanks for joining in, folks. We're right on time. But yeah, if you have any follow-up questions on how to architect your application for Mongo or for other use cases, feel free to reach out. And we'll also send the recording to everybody who's attended this webinar as well. Yeah, thanks for joining in. Then see you on our next webinar.